Hello everybody. Thought I'd make one last video about hypothesis testing unless there are other questions that come up. And I wanted it to be this one that you're looking at right here. Okay, now whenever we try to solve a problem like this regarding hypothesis testing where there's a whole scenario to read through, I have to read through it and extract certain pieces of information. Okay, so for example, let's see, hold on just a second. Okay, I have to figure out like that there's a sample taken and there's a sample size and a sample mean. There's information about the population, and then there's the null and alternate hypotheses. Okay, so I got to figure all that out just from reading it. So when I read this one, I'm reading it with that in mind. And here's what it says. It says a nutritionist claims that the mean tuna consumption by a person is 3.2 pounds per year. So they're, well, what are they talking about? The population or the sample? They're talking about the entire population. Nothing's been mentioned about a sample yet. The sample comes from the population in order to study it. So that's a claim about the sample or the population mean, 3.2 pounds per year. That's definitely a claim about the population mean. And it says, okay, well, a sample of size 60 people taken from the population shows that the mean tuna consumption by a person is 3.1 pounds per year. And so the whole idea with hypothesis testing is, well, I mean, is that different enough than this number to start to question it? Okay, basically, that's what hypothesis testing comes down to. The thinking there is, if this number was way, way different than this one, then we might start to question whether this one was the truth. All right. Now it's hard to judge just looking at the numbers without doing any math if this number is different enough than that one to start to question that the mean tuna consumption by a person is 3.2 pounds per year, but we'll go through, we'll do the math, and we'll make a judgment. From there it says population standard deviation is 1.06 pounds and the level of significance for our test is 0.02. Okay. So here's what I read amongst all that. We've got a sample, 60 people, mean tuna consumption for the sample, X bar, 3.1 pounds. There's the population, standard deviation for the population, 1.06, and then it was stated there in the question that the mean is 3.2 pounds. Okay. Test significance, 0.0. Oh, I think I wrote that down wrong. 0.02. Okay, whoops. Hold on just a second. Test significance 0.02. Okay. And then the claim that is within that problem about the population mean is that the population mean is 3.2 pounds per year. Like that was this very first sentence in this question. That is the claim about the population mean right there. Okay. Now, from this claim, I extract the null and alternate hypotheses. Okay. The null hypothesis always involves an equal sign in some way. It will involve equals explicitly, or less than or equal, or greater than or equal. And here this just involves an equal sign, so that is the null hypothesis. Okay, and then the alternate hypothesis is true if the null hypothesis isn't true. So suppose it's not true that mu, the population mean, is 3.2. Okay, what's true if this isn't true? Well, it's like, what's every other possibility? Is mu is not 3.2. So together, the null and alternate represent all possibilities. If this one is not true, this one is, and so on and so forth. Okay, all right, so that's how we'll work with figuring out the null and alternate hypotheses. Now, the procedure from there will look like this. So I need to open another. There we go. Okay. So the procedure from there will look like this. Okay. I first calculate this thing called the standardized test statistic. It's X bar, the sample mean, minus mu, the population mean, times root n. N is the sample size, divided by sigma, which is the population standard deviation. In this case, I put all those numbers in. I get negative 0.7308, but I'm going to round that to negative 0.73. The reason, well, in MyMathLab, there will be indications for rounding. It says rounded 2 decimal places, so standardized test statistics, z is equal to negative 0.73. Okay. The next thing is, oh, sorry, I got another thing I need to change. It's not a right-tailed test. This is a two-tailed test. Okay, so let me show you why and the rationale behind the two-tailed test. So here in my own notes, 3 scenarios of hypothesis testing. And it's either that you'll be given that H naught is greater than or equal to a number. That'll be a left-tailed test. Here's how that works. H naught is less than or equal to a number. That's a right-tailed test. That's how this works. Or if H naught, the null hypothesis, is just a statement of equality, it says equals a number, then the standardized test statistic could be positive or negative, and it'll be a two-tailed test. Here's how it works. You've got your standardized test statistic that is somewhere on this graph, okay? We got negative 0.73. Then we calculate the area to the left of that, if it's a negative number, or to the area to the right of that, if it was a positive number, okay? That area is P over 2. Then we double that to get P, and if P is less than or equal to alpha, we reject H naught. So here's how I would take this and apply it to what I have in this particular problem. I'd say, okay, well, my test statistic is negative 0.73, and I'll find the area to the left of that in this tail over here. I could, if I wanted to, I could put positive 0.73 and find the area to the right of it. It's like the same result, but this is the number I got. That's what I'm going to use. I'll find the area to the left of that on the standard normal curve, and that will be P over 2. So let's do that. Let's get our standard normal curve. And here by default, when I go to StatCrunch and I open, I'll open it from it. So we go to Stat, Calculators, and Normal. By default, it opens the standard normal curve, which is the normal curve with a mean of 0, standard deviation of 1. Now, I wanted to know the area of the curve left of negative 0.73. Okay, so I get this. So the way I would read this is the area there left of or less than negative 0.73 is 0.2326950. And I get that whole number. Okay. So, all right, I know that area in that picture was 0.232695, but that's not our p-value. In a two-tailed test, that's p over 2. So I say p over 2 is that area I just got, 0.232695. It's important to notice in the notes that, yes, when you get your test statistic z and you calculate that area, that's P over 2, all right. So I gotta remember that I multiply that number by 2, and that's how I get the p-value. So here I also rounded this to 3 places because in MyMathLab that's what it said to do. So I say the p-value is 0.465, round to 3 decimal places, because when I multiply this by 2, then that's what I get to 3 decimal places. Okay, now, all right, I've got that number p, the p-value, which is the deciding factor in hypothesis testing. We would reject the null hypothesis if p, okay, which turns out to be 0.465, is less than or equal to alpha, which is 0.02, and not even close. You're right. I mean, this number here, 0.4, is definitely not less than that one there, 0.02. So I would reject the null hypothesis if that was the case, and it's not. So I'm not going to reject the null hypothesis. And the null hypothesis is the one that I take to be true. Okay, so as I look at this, I say, all right, that's did not reject that, and that is what I think is the truth. Okay, all right. Now, so what the truth being that, well, the sample isn't enough to question this original number. You know, it was originally believed that the mean tuna consumption was 3.2 pounds per year. Then a sample of size 60 getting an average of 3.1. I mean, that's not so different than 3.2 to start to disbelieve that number is what we're thinking. So we think that this is the truth, that the mean, population mean is 3.2. Now, as far as answering from there, we would say we'd fail to reject H naught. There's not sufficient evidence to reject the claim that the mean tuna consumption is equal to 3.2 pounds per year. Okay, so that'd be the right way to phrase our final decision about it. Okay, now if like we were to regenerate this question and change the numbers a little bit, if this starts to get different enough from that, then at some point, you know, think about it. Like if this number was the truth, do you think you could pull a sample and get an average like way, way, way different than that? Probably not. You know, so if, you know, we could redo the problem, you know, MyMathLab might change the numbers up as you work the problem over and over, if that's what you do. Yeah, if that number becomes different enough, at some point it reaches a threshold where we start to question this one. Okay, so ultimately, you know, behind all the math that we do here, where it's kind of hard to get lost, or it's kind of hard to get the big picture come clear through all the details, but yeah, that's the big picture, is that the sample can invalidate the claim about the population. All right, and that would be rejecting the null hypothesis in this case, which didn't happen, but it could work out that way. Nonetheless, that procedure won't change, and this is how you would do it nonetheless.